Hello. Hello, Sayın Hocam. Can you hear us?
Yes, we can hear you.
Okay. Can you close your speaker? Federica, can you close your speaker? So why there's an echo? Microphone, camera.
I think there are two of them. They are in the same place. Maybe no.
I'm not sure. No? No, it's okay, I think. Okay. So yesterday we made a case study, Hocam, and we will send the video link for you. We record the video, so in that case study, our students and our professors from architecture department made a demonstration to show how they are measuring the building, how they are handling their lesson. They use the tools, the real tools, which we will add to our model as an interaction. So it was very informative for us and also for our Italian partners. They can understand better why we are doing this project. So we will send you this video. When you watch this video, I think you can understand, you can better understand what we are really doing. So today,
Yasin, can I ask one question about that video? Do you think if I can share this with our architectural students in Birmingham City University, would it be possible, or just keep it between us?
You can share, no problem.
Excellent. That's good. Thank you.
We will prepare the video. Some our staff is now interested in preparing the video. When they made ready, we will share with you. You can send it to your architecture department as well. So this is the basic studies to extract the building model, to building floor plan by measuring the building, and they are using some tools. So it was a demo, and the project members can understand better in your site by watching this video as well. Now, our Italian partners will present us about how to model in Blender. So if you are ready, can you connect system? I think. Okay, we are waiting.
Yasin, the other thing, you know, the presentation about the models yesterday.
Yeah.
So I believe it will be also made available to students to watch.
Of course.
Yeah. Okay.
All the videos of our activities you can share them. No problem.
Are we planning to post it at the project website?
Yes, we can add them when we are very busy in that period, but when we complete this activity at the end, we are keeping all this information and we will share them in our website as well.
Okay, that's fine. That's good.
Okay, so
On the microphone and okay. Do you hear us?
La slide qua, già che vedete. Della 8, no? C'è dalle mura. No, siamo...
Mi sentono?
Do you hear us? Sì.
Can you hear us?
Your speaker is on or off? We will.
It's
Yeah,
on.
we can hear you. No worries.
Okay.
We just muted ourselves to listen to you just in case of any echo or so on. But your sound is sound and clear. That's and everything looks good. Yeah.
Okay, perfect. Thank you.
Okay, so yesterday we talked about the story of the two towers, Torre Pali and Torre San Foca. Now we are going to present you how we modeled these two towers. As for the openings, we started with a cylinder, tapering it upward to build the base of the tower containing the water cistern. To this, another outer was added with a larger diameter of 2 meters. Most of the coastal towers have double walls to better defend against enemies attacked. In some cases, between one wall and the other, there was the presence of an access with the stairs to the upper floor, but this does not seem to be the case of the presence of a stair. Since there are no signs that this existed. So next, the same step was made to model the second floor of the tower without tapering the cylinder, without taping the cylinder, and a shrinker's frame was made through a torus, the object torus, to separate the two floors of the tower. Then the openings were made, including the machicolation. The modifier tool most used was the Boolean, which made it possible to create complex geometric shapes from the intersection of simple geometric objects.
These are machicolation.
Using the same tool, the Boolean modifier, it was possible to obtain the loopholes, which are windows that open from the inside to the outside, that allowed the monitoring of the enemies attacked, the arrival of the enemies, but without being attacked by them. The same process was done to carve out the doorway to the chamber, to the intersection of a cube in the cylinder, with also the modifier Boolean. The terrace was built on the upper floor, separated from the rest of the building by a string course. The little wall bordering the terrace was made from a cylinder intersected with another one in order to recreate the hole in the center. Afterwards, the upper part of the little wall was made steep, inclining the upper faces slightly to come as close as possible to the real model of the coastal tower. Again, using the Boolean modifier, the mouths of the machicolation were created from above through the union of several cubes, as you see in the picture, intersected with the terrace wall. Then the garret was created, which is the sighting place of the sea to which two cylindrical columns were attached. And finally, the last two openings involved the round trapdoor that provide access to the terrace. And the mouth of the cistern on the second floor was rendered in the same way through the Boolean modifier the intersection of cylinders. As for the roofs, the domes were created through the separation of a sphere, and unnecessary faces were removed for both of the second floor. While for the ornaments and the furniture, smaller objects were created. In particular, we created shelves for the upper stringer, modeled from two overlapping and cut cubes. Once a semicircle of shelves was created, through the modifier mirror, it was possible to reflect on the y axis the semicircle and obtain a complete circle. The furniture elements were made from cylinders and cubes, such as the trapdoor, the latch door, the stairs, and the grating, covering the mouth of the cistern. As for the outdoor environment, the bridge, this was a stair, the cistern. So as for the outdoor environment, the bridge that was supposed to connect the tower to the beach was modeled by the intersection of two cubes, one of which had an arched upper face. Then, through the modifier array, it was duplicated along the y-axis until a 5-arch bridge was obtained. For the cliff on which the tower rests, on the other hand, the subdivision surface was used on a cube, and then in edit mode, the individual vertices were randomized along the z-axis with proportional editing to obtain an imperfect surface similar to a cliff on the sea. The second step of the modeling was the texturing of the sea.
This is
the final model without texture. The second step was the texturing phase. The UV mapping technique was used to spread the texture on the model, on the geometric shapes modeled. And in addition, we use nodes to connect specular, color, roughness, and normal texture together in order to have a more realistic rendering. We used materials as a result of historical research on the area and a comparison with the contemporary coastal towers. Specifically, a texture of pietra leccese was used for the string course frames, corbels, and the interior of the tower. This pietra leccese is a very porous and easy to work that distinguish the Salento area. Carparo was used to the exterior cladding of the tower and the bridge.
There is a little bit of latency between the.
This is the texture for the rock with the seaweed, for the cliff. Coccepesto was used for the interior flooring, composed of mortar and crushed bricks. And then the assembled wooden planks for the door, trapdoor, and stairs.
This.
Finally, the model was rendered through the Cycles render engine after setting the lights in the environment. And now I'll show you some renderings.
Some screen of.
This is the second. No, not the second talk.
For rendering, this is a video, but because of the fact that the Cycles, the render engine was Cycles.
It's a little bit slow.
No, only Cycles. We have worked on only with Cycles. For the rendering, yes. For the rendering, yes.
As for Torre San Foca, Torre San Foca does not have much information to draw from. There are only a few old photographs depicting the tower partially collapsed before the restoration of the last century. Also in Torre San Foca, we found the defensive elements of the thrones for the fire mouths, but it turns out to be a more compact body with fewer openings. Unlike Torre Pali, the entrance to Torre San Foca, the entrance were on the ground floor, while the windows were on the second floor, defended by the machicolation. Inside the tower, on the ground floor, it's assumed there was the mouth of a cistern, probably dug into the rock, while the passage between the two floors had to come from inside by ladders used when necessary. So as for the 3D modeling of Torre San Foca, it turned out to be very similar to Torre Pali, but with some differences in the architectural structure. The first difference involved the square plan, while Torre Pali was circular, and the use of cubes were...
Can we provide a better interconnection for you? Because
10 seconds break, okay? So
okay.
change the direction.
yeah.
Okay, I stop one moment the presentation.
Yasin, the screen has been
Okay,
frozen.
here we are. Yes,
Okay.
here we are. We changed the internet connection, so I share my screen. Okay.
So
Do you hear and see the screen?
Yes, we can see
Do
the
you-
screen now.
Okay, perfect.
So I start again with the 3D modeling of the second tower. The modeling of Torre San Foca turns out to be similar to Torre Pali, but with some differences. One difference involved a square plan and the use of cubes rather than cylinders for the openings, for the walls, sorry. About the roofs, hipped walls were recreated through the intersection
I think there's still frozen. It may be bandwidth issue.
Do you hear us now?
Now you switch the screen, yeah.
Okay, we try again.
So about the roofs, we created hipped walls through the intersection and the successive joining of two half cylinders. And then the cistern. The cistern was probably smaller in size and square. In order to model the mouth, we use sculpt mode to act on a cube to make the rock imperfect. Windows were present only on the upper floor. Very simple.
Problem connection. Okay, here we are.
So about the windows, I was saying that they were present only on the upper floor with very simple and geometric shape, unlike the windows in Torre Pali. And now, finally, everything was textured doing the same the same process, the same step described for Torre Pali. We use the cycle rendering and
these are other screen of rendering of tower of San Foca. No, tu vai. Okay. This is the tower inside with the new a render with the fisheye camera in order to see
all the walls.
All the walls and ledger which links the first floor with the second and with the terrace. And thank you for your attention. If you want, we can show also the model on Blender if there are any question, any particular question on Blender. Aspetta, te lo vuoi trovare su... One moment.
No, no, non è l'Excel, è
It's my
here there is the 3D model.
So strange things that when I moved this project on my SSD,
We have some problem with the texture, but we can resolve it on Unity.
it was resolved on Unity.
Yes.
But when I moved this project on this this SSD,
Even the surface of the castle,
Yes, the texture of the surface.
the upper side of there's like a circular shape over there. There are scratches of some kind of.
This is the
Don't you have EV render? Because it's faster than cycle render.
Yes.
Can you just say click Z and
yes.
Lo provo a mettere io.
render?
allora,
Sì.
Not that beautiful, but faster, much faster.
Yes,
yes,
it's faster. But we have this problem because we moved the file on this SSD, but the texture is okay on Unity
I
because
can
we.
help you actually in fixing this. I can help you.
Ah, okay. Thank
Okay.
you. Thank you so much.
Something about polygon, some geometry. I think we have to fix some geometry. There's a problem. Okay, so maybe can we go to the material? Let me check.
Yes.
Can I just? No, I just want to see the model.
the
first.
material or
No, I
solid?
think this is fine. So it is going to be fine. So can I see it on this collection? Maybe.
What do you?
Can I just Can you see me? Can you tell me
Okay.
in the scene collection?
Yes.
Just select it in.
Allora,
Which part? Yeah, here this one. So okay, it's already selected.
Esterno.
non
il
so se è
secondo piano.
quello però,
Sì,
sai?
dovrebbe essere.
No, because
I don't. This one. This is the
Yes.
surface, right? So is this the surface?
no,
There are-
because
there
there
is
are another cylinder.
Which one? Can we select that one,
This,
please? The problematic
yes.
one. Okay, shift height. Can you click shift H?
Right.
Shift H. No.
Oh, it's okay. Just like this. Should work.
No.
This.
So Here we had solidify. Okay, to solidify,
Yes.
applying this with Boolean, it's problematic. So you have
Yes.
to apply it and then clean the geometry.
Okay.
Yes, we have to apply solidify for Unity because Unity without solidify modifier.
I know it is one single sided. I know,
Yes.
but yeah, I had the same problem. Can we make it apply? Just simply apply it and tab it here.
Okay.
Okay, it's because of the n-gon problem. If you want to make the perfect geometry, it should be quad. So here, for example, this is quad. Another quad are good, but this one is like, look at here, look at the geometry.
Yes, yes, yes.
And the first solution could be merge by distance, so we can remove some. You see, remove
Yes.
233 vertices. There are so much geometry inside. So
Okay.
you have to clean them. This is one way. Another way is we better to make them quad, all of them, because there are some overlapping faces, and this overlapping faces we want to
Yes,
keep
the
fixed in
solidify.
Unity.
Yeah.
Exactly.
The problem of solidify.
And then the other problem is like, again, n-gon problem. You see, there are so many polygons here, like first two,
Yes, yes.
3, 4. It's like a 50 gon, something like that. It should be quad actually. To make
Okay.
it quad, we try to make something like that. Merge them and make everything is quad, like one here, maybe one there. Make them all of them quad. It will be perfect for texture and for Unity game engine. Anyway, we can just talk about this.
Yes,
this
thank
meeting.
you, thank you.
Thank you. So,
Okay, I saved.
You can say it. Yeah.
Yes.
okay.
And having so many geometry, maybe there are some unhidden area, it will increase the number of polygons and it will be a
Yes.
problem for Unity game engine as well. Because this is virtual reality, we are using Android devices.
I know.
It will make the performance lower. Anyway, we can just fix this together.
Yes, thank you
Okay.
so much.
Thank you.
Okay,
Okay.
so
there
we
are-
finished the. If you want to
Okay, so
see others.
you can, if you can close
Yes.
your microphone and speaker, I can take the control. So thank you for your presentation, and we can pass to the next phase actually. So in the next step, we will overview our curriculum plan. One of our output is a curriculum. This curriculum is for computer science students. So computer science students and professors. In our project proposal, we propose to create one curriculum for developing historical buildings VR model. So it will include also interaction. So actually, this is the abstract of what we are doing. So actually, we have prepared a template. Now we will overview this. So I suggest something about what you have prepared up to now. Then also we change some parts. So we will discuss together. Then we will finalize our curriculum. So I'm sharing my screen. You will see. Okay, this is our curriculum plan. So the course title will be Designing Interactive VR Application of Buildings. Actually, we didn't specifically say historical buildings. Okay, so this subject can be extended. The normal buildings for normal. We can use this courses in different aims. The architectural aims for cultural buildings, historical buildings, or modern buildings. So we give a title like this: Designing Interactive VR Application of Buildings. So prerequisites of this course. So the student must know a basic level of structural programming skills. They must have these skills. Also, they must know object-oriented programming, especially C#. If they have experience in C#, it's better. And also basic 3D geometry, vectors, coordinates system. They must know this mathematical background. Actually, they must know to take this course. This course is maybe for undergraduate students, or also for master program. That can be a master program course as well. So general objective of this course is teaching architectural modeling, teaching architectural visualization, teaching to develop VR apps, teaching to design and implement interaction techniques. So the first topic of our plan is, it includes an introduction to the 3D modeling. So the professor will teach, will explain definition of a 3D model, what a 3D model is, and he will explain history of 3D technology, and also application fields of 3D modeling. 3D modeling for architecture, this is a specific subject. So because our curriculum plan is for architectural buildings, and also challenge and opportunities in this field. So as a learning outcome, students will gain awareness of 3D modeling, also awareness about history of 3D technology. So I want to say that actually there was a misunderstanding when in the first template. So these are the subtopics, but we don't have to match them with learning outcome. Perhaps we have to match the learning outcome with the subtopics, but teacher-centered activities or student-centered activities, we don't have to match them. Okay, so teacher-centered, when we are saying teacher-centered activity, so what teacher will do in this lesson, what kind of methods he or she will use, and student-centered activities, what students will do for learning this topic. So we don't have to match these activities with the subtopics one-to-one. So general. So actually there were one-to-one matching in your first template. I a little bit change it. So students understand the potential of 3D modeling. What teacher will do? How can he teach? He can use with slides, lecturing with slides. Also, he can use question and answer method. So especially for 3D modeling, to better understanding, he can give example, ask question, and students will answer. And also they will make discussion about 3D modeling in this topic. What can students do? They can discuss in each other the first impression about the 3D modeling. They can search on the web the history of 3D technology, the milestones, and discuss. They can discuss the future development, and also they can prepare 1-minute paper. This is one of the pedagogical way. At the end of the lesson, sometimes teacher may request student to write 1-minute paper. So they will summarize what they learned in this lesson. So what kind of research and materials will be used in this lesson? Slides and videos can be used. And in the second topic, building a 3D model. So open source commercial software for 3D. These are our subtopic: open sources and commercial software for 3D modeling. Introduction to Blender. We have different options. Blender is the open source environment. There are 3D Max, or there are different options, but Blender is the best option because it's open source, and also powerful as much as the other ones. Yeah. So editing tools, modeling steps for architecture, creating and modeling objects. So as an output of these lessons, students learn 3D modeling fundamentals. They can understand the Blender software. They can use actually Blender software. Students experiment the editing tools of the Blender. Students understand the 3D modeling process. Students create their own 3D model. So as a basic level, they can create a model, a 3D Blender model at the end of the first lesson. Actually, this is the building. This is not week, okay? This is a chapter. Maybe this chapter can continue 2 weeks, or this chapter can continue during 2 weeks or 3 weeks. At the end of this chapter, student can create a basic level of model, Blender model. So teacher-centered activities is lecturing with slides, tutorial and demo on Blender. So teacher will make some demonstration on Blender. So, you know, we must install the Blender. Teacher must also install the Blender software, and he will teach the modeling steps one by one by demonstrating on the computer. Tutorial and demo on Blender. Actually, these are repeating, but this is what I said at the beginning. We don't have to repeat them. Okay, this is the way for each subtopic. We don't have to express the methodology. So we can generally say lecturing with slides, tutorial and demo on Blender is enough, I think. So what students can do, installing and using Blender in the first step. Practical activities, actually, we must extend this subject. What can they do? Practical activities, but what can they do as a practical activity? They can, for example, model a basic cube or a building, something we can, in detail, we must write it in detail, because this is a guide for teachers and students. And as a material and resource, slides and PC, a student and teacher need a PC and also slides in this topic. And editing 3D model is actually the second part of the building a 3D model. So after building a 3D model, student and teacher must edit them, right? So editing is important subject, because all the things you explained in the first part is about the editing, right? After creating a model, editing is an important details. What is it? Nodes and materials, texturing, practical settings, lighting and environment, rendering and exporting. These are the subtopic of editing the model. We can also add something, Kasım hocam, unwrapping. We can add unwrapping to this.
Yeah, maybe texture you can say UV unwrapping and texturing could be. And it's fine.
So as an output, student can practice coloring the 3D model. They can texture the 3D model. They can add practical settings, add lights to the model, render the model, and export it in various formats. So teacher will make demonstration on the Blender for all this. Also, I don't know, they can use slides maybe for some explanation, for some details. Also, they will made demo on Blender, live demo, right? Live demo on the Blender, because during the lesson they will use always computers, and they will demonstrate what they are doing, how they are editing the model. So the most teacher-centered activity is demonstration, demo on the Blender on the PC.
The lecturer will do it, and the students will watch it, and after that they will try.
Yeah. So demo is right. Demo is student is watching what the teacher is doing, then applying them. Yeah, they're repeating, and by this way they are learning how to edit the model. And also practical activities, we must extend it. Okay, we can add detail. What can they do? They can, for example, texture a cube or something. We can give extra definition. PC is also assigned resource, and actually we want to discuss the photogrammetry. Do you think is it really necessary for this subject? Photogrammetry is a different area, totally different actually. So
we can extend the previous model, and cancel the photogrammetry model.
Photogrammetry is another way. Yes, we can use photogrammetry, but for photogrammetry, it needs a background, right? So computer science students, they don't know actually photogrammetry. Generally from geography department, they are, or geometric departments learn photogrammetry, so they don't have a background. So it will a little bit changing the concept actually. So we can, yes, it's specific, really specific for maybe it can be another course. If you are willing, we can cancel this. We can exclude.
It will be complicated right now.
Yeah.
Because it's a geometric model, also standard, the geometric model. Yes, we can focus.
Exactly, because we will have one semester curriculum here. If you include the photogrammetry, I think it will take around 3 to 4 weeks, maybe.
Yeah, perhaps more.
It's really hard task.
Yeah.
So maybe we can exclude it. Because after that we talk about VR and then how to put the model in game engine and then make a whole project, like VR project.
So the next, actually, we are a little changing the concept and also the subject. After modeling, we complete the modeling process. Then we are passing to virtual environment. So introduction to virtual reality technology. So the subtopics, we will first give information about the history of VR technology, challenges, opportunities, and what the VR elements. We must define them. So there are one of the most known VR elements are headset, but there are different tools as well. Some gloves, right? Kasım hocam, there are some different elements. We can give examples. We can show them if we have a laboratory. We can show the students these VR elements, with these VR devices.
Differences between the technologies, and then.
Also, I think so. Today we are virtual reality. Also, metaverse is a trend topic. So I think we will see new devices in this area, not just helmet. And every day they are working on to create new devices about virtual metaverse, virtual reality. So this is an important subtopic. I think we must recognize. We must introduce students these VR elements.
The new Oculus, by the way, is on the way.
Yeah, new Oculus is coming with cameras.
It's quite nice actually.
Yeah.
It will have, I think, a RGB camera around it. Now it's the current one is black and white. It will be RGB. I think it will be.
And also we are planning to make another research, but if also some camera to see your eyes, right?
I think they are planning to have an eye tracker.
Eye tracker. So it will provide us many research area actually if they develop these kinds of VR headsets. So it's opening the new research area. We can apply these VR devices to many area.
Yeah. Also, in order to interact in the virtual environment.
Yes.
Yeah. If you have
It increased also interaction.
Sensation.
Yeah. The life is going too virtual. Yeah.
Yes.
So in this chapter, students will gain awareness of VR technology, can use VR equipments, and learn usage of different VR in different fields. Teacher will use slides. Also, he will make demonstration or do VR devices and VR products. What VR products? So VR is not only consist of devices. VR is a technology, has software as well. So there are many VR products. So actually, we are producing a VR product now. This is a product. There are different. Metaverse is also a product of VR technology. So students can test VR equipments, discuss the first impression, searching the VR technology on the web, on the internet. So the materials of the courses will be slides, video, and VR equipments. And then we will pass to the next. Actually, it's not the phase, but the next chapter is game engine. So when we create our model, we must transfer this model, this Blender model to the game engine. So the most used one is Unity, right? We will, yeah, we say game engine, but we are using Unity. Introducing and installing development environment, Unity game engine. This is Unity game engine, Unity surface interface and menus, Unity assets and components, deploying an app to the devices. These are the subtopics of this chapter. In this chapter, students comprehend the game engine fundamentals. They will familiar with the game engine editors, run their first application in Unity, and deploys this application to the VR devices at the end of this chapter. So the teacher can use slides, make demo on Unity game engine editor, and he can also use question and answer method. They can discuss actually in this chapter in detail. Also, they can make a demonstration on VR devices. So student can install the game engine editor, run their first sample application on editor. Also, they can deploy the first app to do VR devices. Also, slides, video, and VR equipments are the material of this core this chapter. In the next chapter, game development fundamentals. So the topics: coordinate system, vector operations, dot products, cross products, transforming game objects, built-in methods. These are the subtopics of the game.
Game mathematics.
Yes, this is actually game mathematics, about the background, the infrastructure of operation in the game engine. So it's about basic mathematics. Student applied mathematical knowledge and skills to the 3D programming, knows how to transfer the game objects, knows life cycle of built-in methods as an output of this chapter. Teacher can use slides. He can make demonstration on 3D model, 3D programming in game engine. This is Unity. We are using Unity. Demo of building methods in game engine. So what can student do? Student can study game mathematics on the paper. This is very important. First, they must understand what is the geometrical background of this transformation, right? So transforming, rotate, so moving, sketching, the mathematical, they must know the mathematical background. So they can make code practicing for 3D programming in game engine editor with C#. We recommend C#. Is there any option?
No.
So now it's just C# is supporting this platform, and they can deploy their so they can prepare also 1-minute paper with the mathematical knowledge, what they learned at the end of the lesson. So we can use PCs, slides, sample codes, 3D vector graphical apps. So these app, you can find this 3D vector graphical app in web. It's a good tool. It's actually a web page. If you search it in a web page, it's illustrating the transformation of object. If you put an object in this environment, you can rotate it, you can move it. So they are showing all the details with the mathematical background. So it's a good tool to learn this subject. So the next step is the next chapter, exporting 3D building model to the game engine. So I'm trying to extend it. Configuring 3D model, set up texturing, set up lighting. So students, as an output, students exports a model into the game engine. Student embedded texture into the material. Student configures environment lighting. Yeah, so it's the realistic. This is when you do this texturing and lighting in good way, so it makes realistic, right? You feel the absence of presence of
game engine cannot like it's calculating the like real life reflection and the other things. It will cost a lot in terms of graphic memory. So therefore, we have to bake them before when we run the game, and after we set up everything, texturing, lighting, models, and we put everything.
Also, this is an optimization, right? It is an optimization to.
You're baking the environment, and it will be like a baked. It's not real time. But now Unity has mixed version. After you just put all lighting, you embed into the texture, you can also have a real time lighting. It's just supporting, but for this one, Unreal Engine is much better. But Unreal Engine is really hard to work with. It's required really high spec species.
So student export the model into game engine, student embedded texture into the material, students configures environment lightings as an output of this chapter. Teacher can use slides, can make demonstration on Unity, and also make demonstration on VR devices. A student can create a study group. Each student create a simple 3D model and export it into the game engine, practicing texturing and lighting on the model in the game, and comparison of each model in the group. So this is one of the best way we can create student groups, and they can actually model the same thing or different things. Then they can compare what they have done. They can discuss in each other, and they can make actually knowledge exchange in each other with this way. So as a course material, PC, slides, VR equipments, and free 3D models. Also in web, you can find 3D models. They can also study on this free 3D models.
You can either create or just get some 3D models, so just take a texture them, put the material in. Because when you create a text and material in Blender, it's different than Unity. So we just want to let them understand what's happening inside.
This comparison is very important.
Yes.
Because
group studies is very important.
To compare the model, but also to prove that one solution will be better than the other one, and this discussion is very.
So sometimes they are not learning always from their teacher. They are learning from each other, right?
Okay. Yes, correct.
So the next chapter is selection techniques. We are passing to interactions.
This is core VR side now. Actually.
Yeah.
So like selection and manipulation.
Yeah, manipulation, selection, highlighting, virtual hand, raycasting. These are the methods. Student can highlight the virtual object. Student select the object with virtual hands and raycasting. Student gains awareness of the state of art selection technique. So it's
we cannot talk about all of them, but just provide some.
Give some, but every day maybe new selection techniques can be created in the future, right? So there are ongoing studies. if we can find good selection models in the literature, we can teach them to, we can explain them to students as well. So teacher can use slides, demo of selection type with role play. So role play is another teaching methodology. So in the class, for example, I apply this model in the class. Sometimes I'm choosing some students and giving some, for example, when I'm teaching deadlock subject in the operating system, I'm creating a group, and with the students, I'm assigning a job to the each student. So we are playing actually a game in the class with students, so they can, like, they're watching the lesson as if they're in a theater. So they are some students, and we are acting, and actually we are illustrating what is happening in the computer. So for selection techniques, we can make a small game, class game, and student can play this with their teacher. So student can make code practicing on selection techniques, can test selection technique in VR equipments, and also they can search and prepare a report about state of the art selection technique. This is important. If they search, they will find many research studies. So there's course material can be PCs, slides, sample codes, and VR equipments. Manipulation techniques. This is translating, rotating, and scaling. These are the core fundamental manipulation techniques. So student will move, rotate, and scale the object in the game engine. Also, this is just one duplicate. I can delete it. And teacher can use slide demonstration of manipulation models in the role play. So, for example, we can use a material, we can use a tool. For example, this smartphone, we can show what is rotating, what's scaling. I can't scale it, it's difficult. There must be a different thing, but we can use some tools to demonstrate what the rotate, scaling, or moving the object as a role play in the class. And demo on game engine editor, question and answer method, and demo on VR devices. Teacher can use this methodology, and students can practice manipulation methods in real life objects. So we will show them in the tool, some tools. They can repeat it actually. Also, they can make code practicing on manipulating techniques in the game engine. Also, they can test manipulation techniques in VR equipment. PC slides, sample codes, and VR equipments. Again, our course material. Mixed reality toolkit. This is a special library, and we use this library in our model. This is very useful, and we have very powerful functions. It's a very functional library for interaction in Unity.
Flexible.
Yes, flexible, and
you can input actions, and you can have provide teleportation. The other things. It's nice actually.
yeah.
It's really rich actually.
Very useful, and it also decrease the developing time. So if we don't use this MRTK library, so perhaps if we complete our interaction coding in 1 month, perhaps by using this we can do it in 1 week. Yeah, it's very useful. So we must explain this toolkit to the students as well. Subtopics integrating mixed reality toolkit to the game engine, its interaction and user interfaces. Student utilize MRTK in game engine, student perform MRTK interaction, student modify and use MRTK interfaces. Teacher can make demo on game engine and on VR devices. Student can make code practice on MRTK library, test MRTK in VR devices, preparation of report regarding MRTK API. And so this topic is about specific for our project, measurement interaction tools for architectural education. So, you know, we have measuring type, hose, plumb, whiteboard, and annotations. So these are specific tool we have created in our project, so we can explain our students how to prepare these interaction tools. Student can develop measurement interaction. Student implements virtual measurement tape, hose, plumb, whiteboard, annotation, and measuring the building. So the teacher can use slides. He can make demo on game engine and VR devices. So student can make a case study examining the measurement process of the real building. So yesterday we made a case study. It was very useful. So to better understanding, we can make a case study to illustrate how we can measure the building with the real hose, real measuring tape, plumb. So student can understand what they are doing better. Then they can start the code practicing for interaction techniques regarding those tools. In the game engine, testing these interaction techniques in the VR devices. So as a course material, architectural tools, measuring tape, hose, plumb, these will be the course material, PC, sample code, VR equipments. And the last subject, the last chapter is multi-user interaction in virtual building. So this is one of the new topics for us as well. We learned we didn't create a network multi-user environment before, so we tried first time in this project, and it's very useful. So today the most important part of the virtual environment is multi-user part. What people want to use this technology as a collaboration tool, as an online tool. So this interaction, the multi-user interaction, is very important. Photon unity networking, creating virtual rooms, adding multi-user. We use also Meta Avatar SDK. This is also very new. It was released in the April of 2000, in this year, in April of. So we are one of the group which use this Avatar SDK the first time. So it was very hard for us because we can't find sample codes. We can find sample codes, sample applications. We learned by trying one by one. So actually we had completed most of the part, but the last 1 month we focused on this Avatar SDK. So now we solved it as well. This is very useful. Also, it increased the feeling of the presence. So it's very increasing when you use Avatar. When you talk, it's animating your lips motion as well. So when you're also, it's animating your gesture as well. So the interaction becomes very realistic, very realistic. I like too much this avatar SDK. So this is why we spent so much time for this interaction, and also interaction synchronization. This is the other subtopic. So as an output of this chapter, student create multi-user VR environment using photon network. Student can develop multi-user interaction in VR, and student implements experience on social presence using Meta Avatar SDK. And teacher can use slides, demo on game engine, editor, and also on VR devices. Student can make code practicing for interaction techniques regarding these tools in the game engine. They can test these interaction techniques in VR equipments. Also, student can customize their own avatar. So it will be very interesting if the student can create their own avatar. Now, this library is not allowing Avatar SDK, Meta Avatar SDK is not allowing to create your own avatar. They have sample avatar and you can use them. But in the future writing, they will add this feature as well. So there are many applications in web. You can put your pictures and they're creating a very similar avatar for you. So now we can't apply this avatar to our model because Avatar SDK is not allowing it. But in the future, I think they will add this property to their application as well. So it will be more realistic. So okay, when I enter the virtual environment, I can understand, I can directly recognize the people. You are Federica, you are Sofia, you are Jada, you are Luci. So we don't have to write their names on the, yes. So it will be very useful. And PC, sample codes, VR equipments, and avatar create app can be the course material. So this is the end of our course plan. I think we are nearly completed. We are nearly complete this course plan. So if we can add, if we can apply this course plan, if we can create a course in our syllabus, in our, for example, in our department, we have master programs, and we are planning to use this course plan in that courses. So it will be very useful. And one of the output of our project will be implemented to the real life. So is there any question? Şey göremiyorum.
Dosya mı?
Yo tabii.
Fotoğrafta VRarch LTT yazıyor ama.
Bu niye açılmıyor? Şu.
Yasin.
Hüseyin Hocam, do you have any question?
Rather than question, this is just
Ses kapalı.
Okay.
a suggestion. Would it be possible to invite externals to contribute to this curriculum, to teaching? For example, now we are talking about metaverse, we are talking about VR and the machines and so on. So we may be able to invite very well-known figure to give a talk for about 30 minutes, maybe 20 minutes. This would help students be inspired a bit more. Can we reach out such people, because this is a funded project, and we may be able to invite them to join our team, and also we may be able to invite an industry to talk about, for example, their equipment. For example, one of the topics that you mentioned is we are going to introduce different types of machines, VR machines and so on. I'm sure the companies would be very happy to come and talk about, or at least record their promotional lecture, and then send this on to us. And this would be very cheap or very cost-effective advertisement for them.
Maybe do you have any connection?
We can definitely reach out people, definitely, yeah.
Okay, so when we finalize them, we can send it to you. Actually, if you have a connection and if you can they can contribute us, we will be very happy, because we are trying to create the best output.
Okay. Definitely. So leave it with me. I'll reach out to people. I mean, would you be able to share that draft schedule with me? Is it ready to go? Can we share this with potential contributors at this stage, or we just wait until we finalize it? I believe it is still a bit confidential at the moment. That's right.
Yep. So actually, we are about to complete it. We are about to. So in our website, in our project folder, in Google Drive folder, we have a copy. But in 1 week, I think, or in 2 weeks, we will be completed all of our study. Then they can contribute, they can criticize, they can comment and give feedback. Then we can change and finalize the last version.
Yeah. Okay.
So
leave
we
it
will
with me.
we will inform you when we complete all our work. We will inform you, and then you can send it to your colleagues and the other companies or the
leave
other.
it with me. I'll get a few names so that the students would be able to see different faces, and also especially from the practical side. Okay. The other thing is that, for example, right at the beginning you said multi-user, and how about multi-objective? So I believe we would be able to cover multi-user, multi-objective interaction within that environment while it's being delivered, taught. So not only multi-user, but also multi-objective in the metaverse environment.
Maybe, but it may be another research subject.
Oh, okay, that's fine.
Maybe another research subject out of scope of others, out of this project. Maybe it can be a good actually study area, maybe a PhD area as well. No.
Okay, and how about, I think as far as I can see, some of these topics would require the use of artificial intelligence algorithms. So where we are going to give a bit of information about the intelligence aspect, the algorithmic aspect.
We discussed this with Kasım Hoca. So this is 1 semester course.
Yes.
1 semester course. So if we extend too much, maybe we can't teach all of them in 1 semester. So it may be one another course plan actually. If so, the artificial intelligence application of virtual reality.
Yeah.
Maybe another course plan. So I think if we get out of the scope, it will be very hard to implement in 1 semester.
Yep. Okay, that's fine. So there may be a kind of a seminar type of work rather than within the curriculum.
Okay. So is there any question, any other question, any comments? Okay, thank you for your participation. For today, we are completing our online session. Yesterday, we visit many places in here. If only you were here, Hüseyin Hocam. Now we will go to the old town and we'll see our buildings are tabakhane buildings. We will examine the buildings, and also we will visit the old Safranbolu with our Italian partner. I hope next time you came here, you come here,
yeah. Looking forward to it,
and we can go with you.
Okay, enjoy it. I just text you, so we have an extra presentation on Friday from one of our colleagues at Birmingham City University. Dr. Pınar Satılmış will be delivering a talk on skylighting for graphics applications. I hope it is possible.
Can you repeat? I didn't understand the topic.
Okay. I just text you if you have a look at. So this is skylighting for graphics applications. So this is very interesting one.
Maybe you want to change the subject. So
no, I will do my presentation, but short. Then I think Pınar's presentation will be also very helpful.
Yeah.
On Friday.
Okay. So on Wednesday, our presentation will be in conference room in our engineering faculty. I think you know there. You have visited our university before. You made a presentation there. So we will reflect the presentation to the wall on our conference room, and all of my class students will attend there. On Wednesday, okay, we have a plan, but we are flexible on Friday because it will be just between us.
Yeah, sure. So this is what I meant for Friday. Yeah.
Okay. So the time is same, right? We are not changing.
So the time is changed. Nothing has changed. Just an extra presentation kindly agreed with Pınar.
Okay.
I thought it would be very useful for the project as well.
Okay. Thank you. It will be very nice, and we can add to our programs, and we will send it to the national agency. Can you write the title of your presentation to us from WhatsApp? I will add to the program it.
Yeah, Yasin, I just text you via WhatsApp.
Okay. If you send, no problem. Okay, so how much time?
We say 30 minutes.
30 minutes.
Yeah.
Just a minute, I will check our program.
Yeah.
Our program. So how can we put it in our agenda? And on Friday, we are starting at 8 with your time. And so between...
Put mine up to half an hour.
Oh, okay. So we are not changing the program.
No, we are not going to change the timing. Just adding an extra presentation.
So then I will add a session, more session, but I will not change the timing. So no problem. Okay. I'm adding this presentation to our program. Thank you very much for your contribution.
Okay, thank you. So all the best. Enjoy your time. Okay.
See you.
Send me a couple of photos then.
Okay.
Okay. See you then. Bye bye.
See you. Goodbye.